Hi everyone, let's start solving today's LeetCode daily challenge, which is 382 linked list random node. So, as per this question, we have given a singly linked list, return the random nodes value from the linked list. Each node must have the same probability of being chosen. So, there are two methods we need to implement: solution and one is int get random. Okay. So, if you given a linked list, let's suppose 1, 2, 3 and 4. So at every time get random get call, so you need to return any random number from range 1 to 4. Okay, this is the size of the linked list, and you need to return any node value randomly. Okay, so if you want to go in a easy way, easy तरीके से solve करना है इस क्वेश्चन को, तो आप क्या करोगे? Simply you will create an array list at the starting when solution get called. Okay, सो जैसे ही आपको सॉल्यूशन कॉल होता है फंक्शन, आप उसी टाइम एक एरे लिस्ट क्रिएट कर लोगे। एरे लिस्ट क्रिएट कर लिया तो मुझे साइज पता चल गया लिंक लिस्ट का साइज कितना है। जैसे ही मुझे साइज पता चल गया लिंक लिस्ट का, उसी टाइम मैं क्या कर सकता हूँ, एक इनबिल्ट मैथ डॉट रैंडम से 1 to n के बीच में कोई भी एक रैंडम नंबर जनरेट करवा के ऑर्डर ऑफ वन टाइम में एरे लिस्ट को एक्सेस कर सकता हूँ। So it is a very easy way to approach this question. Very easy way. That what are my observation? Like if I try to write my observations, what was the observation? The solution will give me the linked list, the whole linked list. Okay, and I need to return random number from linked list at the time when get random get called. Okay, so these are the two observation. And as I know, like if I want to go in a very easy way, I will do this. I will follow this approach: array list mat.random. That's it. Okay, let me show you the code of this very easy approach. So what I just did, I created an array list. This is a global array list. Okay, range. At the time solution get called, I am pushing all my elements into the array, creating a random number, generating a random number using math.random and within the range.size. Okay, and simply returning range.get, like array particular element. Okay, in order of 1. So this function is order of n, and this is order of 1 basically. Okay, so but the space complexity here is order of n due to array list, and time complexity is also order of n. But you are sitting in an interview right now, so you came up with this easy approach. Now the interviewer is asking for a follow-up question. What was the follow-up question? If you scroll down in this question, there is a follow-up question. What if the linked list is extremely large and its length is unknown to you? What is the interviewer is asking कि आपको एक लिस्ट दी हुई है, लिंक लिस्ट, जिसका आपको साइज ही नहीं पता है। आप अज्यूम करो ये। You need to imagine there is a linked list or there is a string with unknown size. So can we resolve it with without using extra space? That is a follow-up question from the interviewer. Okay. So this can be resolved if we broad our mind. If you if you want to stop at the easy solution, that is totally up to you. But if you want to broaden up your mind, so then we will came up with an algorithm which is nothing but, sorry, this is the spelling, reservoir sampling. I will tell you the simple way to understand this algorithm, very simple way. Just keep your focus here. Just listen it. I will use very simple words. So the understanding of this algorithm will be very easy. What is the simplest way to describe this algorithm? is the reservoir sampling algorithm. What does this sampling algorithm says? Like I will choose k elements from n numbers. N is not defined to me right now. Okay, it can be a stream or something, anything. Choose k element from n numbers. What is the main thing in this we need to implement? We need to make sure each element which gets selected has should get selected. Sorry for the bad handwriting. Should get selected with the same probability. Same probability. Keep in mind. Same probability. कि अगर k एलिमेंट्स चूज करने हैं n नंबर्स में से तो उन सभी k एलिमेंट्स जो भी मैं चूज कर रहा हूँ उन सभी की प्रोबेबिलिटी सेम होनी चाहिए. ओके, keep this definition in your mind so it will be very easy for you to understand. Okay, now what if I selected, now why this reservoir algorithm I am using? Okay, I will give you one scenario. Let's suppose you are given a linked list 1 2 3. You are picking a random number in this range. The time you are picking this the number from this range, I added few numbers from here side and added few numbers from here side. But as per our easy approach, जो हमने ऊपर देखा था एरे लिस्ट वाला, एरे लिस्ट में तो बस ये तीन एलिमेंट्स ही है. उस टाइम हमने ये एलिमेंट्स तो कंसीडर ही नहीं किया अगर लेफ्ट या राइट से ऐड हुए तो एज पर इंटरव्यूअर और एज पर द प्रॉब्लम जनरेटर what he wants to ask, think in that way that the size is unknown to me. There is a kind of string is given to you. Now you need to give me a random number with an equal probability. Okay, so now let me give you a small example. Let's suppose we have a stream 1 2 3 4 and we need to pick random three elements from it. So we will create a reservoir. Okay, as per this algorithm, the reservoir, there is an array named as reservoir, which will first pick the first three elements. Now the probability of picking randomly these elements, probability I am saying, probability will be 1 by 3 of picking every element. Okay, because there are in the reservoir there are three elements and the size is also 3. Okay, so the picking every element is 1 by 3. But now what if 4 came into the picture? So if 4 came into the picture, I need to pick now three elements only. So one of the element will get replaced. One of the element will get replaced if I need to pick 4. If 4 came into string, I need to replace one of the element from this. So what will the probability in this case? So probability will be nothing. So let's suppose like 1. For 1 I will see the probability. So for 1, 1 stays with the probability of 1 stays with the probability of, so what if P of 4, probability of 4 will not get selected. Probability of 4 at the time when 4 is not selected, because there can be a chance, no, because 4 cannot be selected, I need to pick random elements. So that will be nothing but 1 by 4, because that is the another element came into the stream, so which is nothing, k plus 1. Okay, one element came into the stream. If two elements came into stream, so the total size will be k by k plus 2. same will be k plus 3 if 3 elements came. Now one element came into picture, so this will be 1 by k plus 1. This is nothing but k plus 1. Okay. So the probability of choosing the probability, what I am saying, P of 4 is not selected. Probability of 4 does not get selected is 1 by 4 plus what if P, what if the fourth element got selected? What is the probability of that? That is nothing but 3 by 4 into, I need to replace either 2 or either 3. So the probability of that is 2 by 3. I can select either 2 or either 3. And if I see this, that will came 3 by 4. Now for selecting 4 randomly in this reservoir array, the randomly picking element, probability of every element get picked with a probability of 3 by 4. As per the definition of the reservoir algorithm, the reservoir algorithm is saying make sure each element which gets selected should get selected with the same probability. Now here the probability of each and every element is same, which is 3 by 4. This is the only thing we need to tackle in this problem. This is the only thing we need to tell the interviewer or the problem generator. Yes, there is a way. If we want to think in that way, if there is a stream given to us with the unknown size, I can use reservoir algorithm. And in reservoir algorithm, what I will do, I will make the probability of selected every element same by using this formula. Now let me write the formula here as well, what we implemented here. So what will be the formula came here? That is nothing. Probability of, okay. What will be the formula? What we did, the element which we need to select. Okay. So let me take that number as x. X was in the reservoir last time. Multiply probability of x was replaced by k plus I. Okay. So from this formula, I came up to this, and the probability of each element get picked up is same. Okay. So this is the simplest definition of reservoir algorithm. Okay, let me give you a brief of this code of this as well. So I created a head, okay, and I put all the values in my head, and this will be order of one operation. Now, in this case, the scope is 1, the K, the size of the reservoir is 1, and here I am selecting mat.random is less than 1.0. Here I am doing nothing, I am calculating the probability, nothing else. Okay, and every time while current is not equal to null, I am incrementing my scope. Okay, and I am updating my chosen value when the probability is getting satisfied. Okay, and at the end I am returning chosen value. Okay, so this is order of 1. This whole thing is order of n. So the whole time complexity will be order of n. The space complexity will be order of 1. Okay, that's it from this current video. If you like this, if this video helped you, so like this video and subscribe to this channel. Thank you very much.